Hi, I'm Ramesh Kumar. I'm the Senior Manager of Product Management in the AWS Snow Service team. Today, I'm going to walk you through AWS Snowcone, a recently announced small, ultra-portable, rugged, and secure snow device that customers can use for compute applications at the edge and to transfer data. I'll also provide you an update on AWS Snowball Edge for edge computing and data transfer workflows. Throughout the discussion today, I'll provide you with some real customer examples. This slide shows the AWS continuum of services from the edge to the cloud. Starting at the right of the slide with the AWS cloud, customers who run their workloads on the AWS cloud receive the full elasticity, scale, services, and online management and monitoring that AWS provides. Moving a little to the left, you come to the customer's on-premises facility. AWS Outposts provides customers with the full services that AWS provides and extends AWS's infrastructure and services to their on-premises facility. If you move a little more to the left on the slide, you come to the rugged or non-data center edge locations. You can see AWS Snowball at the bottom of the slide, and AWS Snowball is suitable for use in austere or rugged edge locations and in environments where there is no consistent network connectivity, such as a factory floor or a ship. On the top of the slide, you see AWS Snowcone. I'm really excited about the customer benefits that Snowcone brings. It allows customers to use Snowcone in a wide variety of rugged edge locations. Customers can use Snowcone in a factory, in a hospital or another healthcare center. They can use it in outside in external environments such as a field or a construction site or on a university campus. They can even use Snowcone on a drone. Then you see AWS RoboMaker, which is suitable for robotics applications. And then you see the set of AWS IoT services that are suitable for smart home and industrial applications. This slide shows the architecture for the AWS continuum of services that are deployed from the edge to the cloud. You see the AWS cloud on the right side of this slide. Customers can use AWS Snowball Edge or AWS Snowcone for rugged or non-data center locations. For an on-premises facility, customers can use AWS Storage Gateway and AWS Outposts. For on-premises facilities where customers don't have a consistent network connectivity, either it's an intermittent network connectivity or it's a disconnected environment, customers can use AWS Snowball Edge and AWS Snowcone for edge computing and data transfer workflows. One of the things we see is that with using edge devices in rugged and edge locations have a lot of challenges. Some of them are listed on this slide. In some usage scenarios, you may not be able to upload data from your edge location to AWS. Think about using edge devices in an external outside location, such as a construction site or an oil rig, where you may not have consistent network connectivity to transfer or upload the data to the AWS cloud. In some other usage scenarios, you may not be able to afford the ability to upload data or transfer data to AWS cloud, especially in edge locations where a lot of data is being generated every day. An example would be autonomous test vehicles, which generate many terabytes of data in a single day of test use. In some other usage scenarios, you may not be allowed to transfer data or upload data to the AWS cloud due to the regulations involved. This could be an environment such as a healthcare facility or a hospital facility where you're capturing or gathering patient data, or it could be financial or other data that is subject to local regulations. In addition, we have to consider industrial devices such as pumps or motors, which may not have been developed or designed with any network connectivity at all. I'll quickly give you a brief overview of the AWS Snow Family for edge computing and data transfers. For edge computing, customers can use the AWS Snow Family of devices to act as an IoT hub, to analyze the sensor data locally, and to make decisions in real time, or carry out machine learning inference at the edge, or implement video or image processing. Customers don't have to send the data to AWS for processing, and they can carry out their compute locally and make decisions quickly, allowing customers to react in real time. For data transfer workflows, customers can use the AWS Snow family of devices to transfer large amounts of data from their data center or other on-premises location to AWS. Customers can use multiple AWS Snowball Edge devices to transfer up to a petabyte of data to AWS, and they can use AWS Snowmobile to transfer up to 100 petabytes of data to AWS. Customers can also use AWS Snowball Edge and AWS Snowcone to transfer data that's collected or gathered in rugged or non-data center edge locations where the customers may not have consistent network connectivity. Over the next few slides, I'll provide you with details on AWS Snowcone and talk about how customers are using AWS Snowcone today. So Snowcone is a small, ultra-portable, rugged, and secure snow device that customers can use for carrying out edge computing applications or transferring data to AWS. The device is very secure. It automatically encrypts the data with 256-bit encryption keys as it's copied onto the device. And it has physical security as well. The keys are not stored on the device. It makes it secure as the device is in transit back to AWS. It's a lightweight device. It weighs just 4.5 pounds or 2.1 kilos. That means customers can carry a Snowcone device in their backpack or even on a drone. You can operate a Snowcone device with a battery and therefore use it in these portable or mobile applications and computing use cases. You can use Snowcone in freezing cold temperatures or in hot climates or in outside locations in the rain. The device, the Snowcone device, has 8 terabytes of usable storage that you can copy data from sensors or machines, and you can store the data on it locally before you're ready to ship the data or upload the data to AWS. Once you've copied the data onto Snowcone, there's 2 options for you to move the data to AWS. One is you can ship the Snowcone device back to AWS using standard shipper options for offline data ingestion or data transfer to AWS. Another option is you can keep the Snowcone device at your edge location connected to the network and transfer the data online to AWS by using AWS DataSync. The Snowcone device has 2 CPUs and 4 gigabytes of resources available for your edge compute applications. I'll provide a few more details on AWS Snowcone. The device has 8 terabytes of usable storage. You can connect Snowcone device to your local network at your edge location, either through a wired Ethernet interface, or you can connect it wirelessly over Wi-Fi. The Snowcone device supports gigabit Wi-Fi connectivity with 802.11 AC and a fallback to 802.11 ABGN standards. The way you operate and manage and monitor your Snowcone device is through a very easy to use, intuitive GUI interface called OpsHub, and I'll talk about that in a little more detail in coming slides. Once you've copied the data onto Snowcone, you can transfer the data offline to Amazon S3 by shipping the device back to AWS. Another option to transfer the data to AWS is to connect the device to the network and transfer the data online to a wider set of AWS storage services, including Amazon S3, Amazon EFS, and Amazon FSx for Windows File Server. You can run AWS Data Sync on the Snowcone device to manage your online transfers. The Snowcone device provides you with 2 CPUs and 4 GB of RAM for your edge compute applications. You can run an Amazon Machine Image or AMI that's developed on EC2 on AWS. You can run that on Snowcone on the Snowcone device, or you can run IoT Greengrass functions for your compute applications. The device just weighs 4.5 pounds or 2.1 kilos, so you can easily carry it in a backpack or a duffel bag or even on a drone. You can use the Snowcone device in outside locations. It's resistant to vibration. You can drop the Snowcone device from up to 4 feet height. It's resistant to moisture and dust. It can operate in the outside environment in the rain and across wide temperatures, whether it's freezing temperatures or in hot desert-like conditions. This slide shows you a few examples of how you can use Snowcone. You can use Snowcone in a healthcare facility. You can use Snowcone in outside environments. It's, as mentioned, resistant to moisture and rain and dust. You can carry it in a drone to capture imagery from cameras. You can easily carry a Snowcone in a backpack. And you can use it in locations, edge locations, where you may not have consistent power supply. For example, you can use it in the picture on the bottom right side of the slide shows a customer using Snowcone in a construction site. They can use it with a battery, and the battery case in the graph is connected to the Snowcone device, and so you don't have to be dependent on plugged-in power supply. So you manage and monitor your Snowcone device with AWS OpsHub. AWS OpsHub is an easy, intuitive, graphical user interface that helps you manage multiple Snowcone devices and other snow devices such as Snowball Edge devices at your edge location. AWS OpsHub is available to our customers free of charge, and you can download AWS OpsHub from the Snow Family and Snowcone resources page. The link to that page is provided at the bottom of the slide. Once you download AWS OpsHub, you can install it on a local host, such as a laptop that's connected to the same local network as your Snowcone device. And with a few clicks on OpsHub, you can set up and configure and unlock your Snowcone device. For running your edge applications, you can use OpsHub to create an instance of the armies that have EC2 instance of the armies that have already been loaded onto the Snowcone device, and then run your applications. To copy data onto Snowcone, you can use OpsHub to set up NFS file transfers to copy or write data onto your Snowcone device. Once you've copied data onto Snowcone, if you want to transfer the data online to AWS, you can use OpsHub to set up, to activate your AWS data sync service and set up and manage the online transfers. OpsHub provides you with a dashboard, and you can monitor the resources used on the Snowcone device, such as the amount of CPUs available, the amount of local storage available on the device, as well as consumption and usage of the RAM memory. This slide shows you an example workflow of how you would use AWS Snowcone for an edge computing application. In this scenario, you have industrial machines that are generating data, or it could be medical instruments generating data in a healthcare facility. AWS Snowcone is a perfect fit for these usage scenarios, be it at a construction site, on a factory floor, or in a healthcare facility such as a hospital or a doctor's clinic. You can copy the data that's being generated by the machines or medical instruments onto Snowcone, either with a wired Ethernet connection or wirelessly over Wi-Fi. If you think about a lot of these scenarios and rugged edge locations cannot support the space or power or environment required for traditional IT infrastructure, and AWS Snowcone is a perfect fit from a space constraint perspective and ruggedization for use in these locations. To set up your application, compute application on AWS Snowcone, you have two options. One option is to develop your Amazon Machine Image or AMI on EC2 in the AWS cloud. Once you have developed and validated your application, you can deploy it on AWS Snowcone. Another option is to develop AWS IoT Greengrass functions in the AWS cloud. And again, once you've developed and validated your application, you can run it on AWS Snowcone. The Snowcone device provides Amazon EBS compatible volumes for your compute applications. And it provides an NFS file interface for data copy and collection and local storage on the Snowcone device. Snowcone brings in a lot of customer benefits for using it to implement edge compute applications in rugged, austere locations, and some of these benefits are listed at the bottom of the slide. Again, given its small form factor, low power consumption, ability to withstand vibration, dust, moisture, Snowcone is a perfect fit for running your compute applications at the rugged edge locations, such as a factory or a construction site or an oil rig or in a healthcare facility. You can use Snowcone to collect sensor data or machine data or data from medical instruments or other instruments, analyze the data locally, and carry out decisions and actions in real time, versus having to send that data back to AWS, carry out the processing, and incur the extra time to drive your actions and decision making. Snowcone provides a consistent programming and development model and DevOps model that you'd see in the AWS cloud. You can develop your application on Amazon EC2 in the AWS cloud first, validate the application before you deploy it on Snowcone. And Snowcone is provided to you and our customers as a managed hardware, which means AWS is responsible for the support, software updates, service stack updates, and is responsible for replacing and upgrading the device if there are any issues. I'll walk you through some typical use cases where our customers are using the Snowcone device. The top left-hand side of this slide is about a set of use cases around industrial IoT. You can use Snowcone on a factory floor or other industrial scenarios such as a construction site or oil fields or mines or other locations where you do not have a consistent network connectivity back to AWS, or you need the ruggedized capability of Snowcone from a vibration, dust, or moisture resistance. You can use Snowcone to collect data from sensors, machines, other instruments, store the data locally on the 8 terabyte local storage capacity on the Snowcone device, and transfer it back to AWS, either in an online or offline manner when you're ready. With the data collected, you can run compute applications to analyze the data, get the results, and make decisions in real time. Another use case is for using Snowcone in healthcare facilities. This could be in large hospitals, it could be in a doctor's clinic, or it could be in remote medical areas or a forward hospital. You can use Snowcone to capture data and store data from medical instruments or patients' data. You can carry out edge computing applications with the data that's stored on the Snowcone device. And Snowcone provides a secure and safe way to transfer the data back to AWS. Another common set of use cases for Snowcone is with content distribution. This is where customers can take content that's stored on AWS and distribute it to their own edge locations or to destination sites at their customers or partners. This content could be media content, scientific, financial, or other content that's already stored on AWS today. And there's 2 ways you can distribute the content from AWS using Snowcone. One is to export or load the data onto the Snowcone device during the Snowcone job order and have the device be physically shipped to the destination location where you want to distribute the content. Another option is to ship the Snowcone device and deploy it at the destination location and then transfer the data online from AWS to the Snowcone device using AWS DataSync. An example of this use case, and I'll talk a little bit about it more in the next slide as well, is Deluxe's One Vision service that they recently announced that allows them to distribute digital movie content from AWS to movie theaters using Snowcone and AWS DataSync. Another set of use cases for Snowcone is content aggregation. And this could be either moving data from rugged and austere edge locations where there may not be consistent network connectivity to AWS, or it could be moving data from machines, other instruments, or movie cameras that's collected out in the open or in external locations where the data is generated, and you can ship the device back to AWS. Think about a filming location where the data from the cameras can be copied onto Snowcone, and the Snowcone device could be shipped back to the studios to get the data quickly to the studios for editing and post production. Or you can capture data from an autonomous test vehicle and bring it to AWS quickly using Snowcone for machine learning and other actions on the data collected. Again, you can aggregate the content by shipping the device, Snowcone device, with the data loaded onto or copied onto the Snowcone device for offline data import into AWS, or you can connect the Snowcone device to the network and upload or transfer the data online using AWS Data Center. I'll talk about examples of how customers are using the Snowcone device. I'll talk about two examples today that are shown on this slide. And if you visit the AWS Snowcone webpage on aws.amazon.com, you can see some other customer examples of how they're using the Snowcone device as well. First, I'll talk about Deluxe. Deluxe recently announced their One Vision service, which has brought about dramatic innovation in distributing digital cinema content. Deluxe makes use of AWS Snowcone, AWS Data Sync, and Amazon S3 to deliver theatrical content and digital cinema content to movie theaters. You can see the quote from Andy Schenkler, who's the Chief Product and Technology Officer at Deluxe on this slide. And you can read more about Deluxe's use case and how they're using Snowcone, Data Sync, and Amazon S3 to achieve their dream and One Vision service at a blog. The link to the blog is at the bottom of the slide here. Second example is from our customer Novetta, who pioneers disruptive technologies in public sector, defense, intelligence, and disaster relief efforts. Snowcone helps Novetta to solve challenges in their use cases and in their workflows by providing them with a mission-ready edge computing technology and device, and helps them optimize their efforts in either disaster zones or other austere edge locations where they can deploy the Snowcone device. The next section, I'll give a quick update on the AWS Snowball Edge device for edge computing workflows. The Snow family includes two Snowball Edge options for running your computing applications in the rugged edge locations. One is the Snowball Edge Compute Optimized device. This device has 52 CPUs and 208 gigabyte of memory for your compute applications. It has an optional NVIDIA Tesla V100 GPU that allows you to run machine learning inference applications at the edge location. The GPU is powerful enough that you could even train your machine learning model if you need to do it based on the data that you've collected at the edge location. The Snowball Edge Compute Optimized device also provides you with 42 terabytes of usable storage capacity. You can also use the Snowball Edge Storage Optimized device for your compute applications. As the name suggests, it's got more storage capability and capacity if that's what you need for your compute applications, or you want to run some data processing and compute and transform on your data before you transfer it to AWS. The Snowball Edge Storage Optimized device provides you with 80 terabytes of usable storage capacity. We recently announced an upgrade to the Snowball Edge storage optimized device on April 16th. And what you see here is you've got more compute performance with 40 CPUs and 80 gigabyte of memory and a terabyte of SATA SSD for your compute applications. Both devices, both Snowball Edge devices, the compute optimized device and the storage optimized device, can be used in clusters for large local storage workflows or large compute workflows. You can deploy these devices at your edge locations for the long term, and we offer 1 year and 3 year discounted pricing for both devices. Let's take a brief look at a customer use case example of how NGA makes use of the Snowball Edge. The U.S. National Geophysical Association is a key stakeholder and sponsor of the AWS secret region, which is readily available to the U.S. intelligence community. NGA is focused on moving data across the world. They provide data everywhere, for example, maps of the entire ocean floor. And what NGA has done, they've created a centralized code repository, an image repository, and data repository that can be shared across their teams. And to make this happen, they created the program Odyssey. And essentially what they want to do is take the data that they've stored at their data center and take it out to multiple edge locations where their teams are based. They used Snowball Edge. NGA used the Snowball Edge devices to make their Odyssey program a reality. They loaded over a petabyte of data on multiple Snowball Edge devices and essentially brought the cloud to their edge location by shipping the Snowball Edge devices with the data loaded into the edge location. And of course, they had to do this for multiple edge locations. At the edge location itself, NGA made use of multiple Snowball Edge storage devices to store their data. They store databases and large amounts of data on multiple Snowball Edge devices. NGA also made use of the Snowball Edge compute optimized devices to run homegrown and applications that they've built to carry out image processing. They also ran off-the-shelf standard applications, compute applications on the Snowball Edge compute optimized device. Next, I'll provide you with an update on the AWS Snow Family for data movement, data transfer, and data migration to AWS Cloud. Just a quick recap on the typical set of challenges that customers face when they want to transfer or migrate data to AWS. So many usage scenarios are cases where customers have limited connectivity options based on where the data is stored or data is collected at the rugged edge location. They may not have consistent network connectivity to transfer the data online to AWS. In other examples, a customer may have consistent network connectivity, but they may have bandwidth constraints in transferring large amounts of data to AWS. Just as a reference, the table on the left side of this slide shows you, based on the amount of data you want to transfer to AWS, the network bandwidth connection you have at your edge location. And basically what you see is that if you've got 100 terabytes of more of data that you want to transfer to AWS, and you've got a gigabit network connection, it becomes pretty onerous and takes a long time if you want to transfer over 100 terabytes of data. In some cases, customers may have high bandwidth network connection, but they may be required for their production use, and therefore they may not be able to allocate that bandwidth to transferring data to AWS. In some countries around the world, network connection costs are very high, which means if you have large amounts of data to transfer to AWS, your cost becomes pretty onerous with those high network connection costs. Or you may have legacy environments or usage patterns or data being collected in remote austere locations such as a mine or an oil field or from an autonomous vehicle at a test location. That makes it hard or even impossible for you to transfer the data online to AWS. That's where the Snow family of devices comes in to help you transfer the data offline to AWS. What this table shows you is the capabilities and options that you have available within the AWS Snow family to transfer data or migrate data to AWS. We talked about the Snowcone device, which has a storage capacity of up to 8 terabytes. And with Snowcone, given its pricing profile, you could use it to transfer up to 24 terabytes of data, either offline by shipping the device filled with data back to AWS, or in an online manner by connecting it to the network and then using AWS Data Sync to manage your online transfers. With the Snowball Edge storage optimized device, customers can transfer many petabytes of data to AWS in an offline manner using multiple Snowball Edge devices. Both Snowcone and Snowball Edge devices are rugged devices that you can use it in edge locations where there's dust or vibration. You can use it out in the rain. And they have an E-Link label for easy shipping automation. The data is always encrypted, the 256-bit key, when it's copied onto either Snowcone or the Snowball Edge device. You see the storage capacities of both devices on the table. If you want to use online data transfer with Snowcone, the Snowcone device comes with the Data Sync agent pre-installed. And to complete your online transfer, you have to activate, you can use OpsHub to activate your Data Sync service and complete the online transfer. You have compute capability available on this device. And of course, this is not an edge compute use case, but if you want to carry out some data analysis or transforms or dedupe the data or manage, you have a managed application to implement your data transfers. You can run your applications on either device to manage your data transfers. You can also use AWS IoT Greengrass functions. And of course, you have Snowmobile. With Snowmobile, you can transfer up to 100 petabyte of data in a single Snowmobile. And of course, you can extend that to exabytes of data using multiple Snowmobile jobs. The link at the bottom of this slide will take you to the AWS Snow Family page, and from there you can read more and learn more about Snowcone or Snowball Edge Storage Optimized or Snowmobile for data transfer applications, as well as the rest of the Snow family for edge compute applications as well. Talk about an example of how Photobox made use of Snowball Edge to transfer large amounts of data from their on-premises data center to AWS. So Photobox is an online personalized photo products company. They have millions of customers. And essentially what Photobox wanted to do was they wanted to get out of the business of owning and maintaining their own data centers and redeploy their resources and their investments in artificial intelligence and other areas to improve their customer experience. And so Photobox had about 10 petabytes of data, or 5.7 billion photographs stored on their on-premises location using EMC Isilon or IBM storage arrays. And they made use of multiple Snowball Edge devices to migrate their data from their data center locations to Amazon S3. And what Photobox realized is once they completed their migration, yes, they saved costs by having their data stored on Amazon S3, but it also resulted in significant higher performance for their websites. It allowed them to scale to more storage capacity later on Amazon S3 than they would have been able to manage at their own on-premises location. And they also have seen much higher data durability on Amazon S3 than what they could have achieved on at their own data center location. You can see the quote from Chris Astall, who's the Group Director of Architecture on this slide. With that, I'll open it up for questions from the audience. Thank you.